Hi everyone, welcome back. So we're moving ahead with section 8.3. In 8.1 we talked about testing the difference between means when we are using independent samples for two independent populations. Now we're going to go back to go to dependent samples where there is a connection between the two samples, and in fact, remember, dependent samples, they have to have the same size, and actually there's a one-to-one correspondence between the values in the first sample and the values in the second sample. Okay, an example might be the weight of a person before and after a diet program. Okay, and in that case, what we're really interested in is the differences between the corresponding weights. Okay, which if we want to test and see if the diet is effective. So really, what we're doing is we're taking two samples where they have of the same size. We have one-to-one correspondence between the entries, and in fact, the entries occur in pairs. And then we want to find the differences between those respective entries. So the DI is just this difference x sub I minus y sub I. All right. So, and what we're going to be doing is we're really going to be making a test about a hypothesis involving the average difference between a value in one population and the corresponding value in the second population. So just some terminology here. So after we take the samples, we take the differences, we take the average of the differences, or the mean, and that's d bar. Then there's S sub d. It represents the sample standard deviation of the differences. That here's the formula for that. We talked about how the sample standard deviation is calculated before. You don't actually have to use this formula. Your calculator will do it for you. But we'll need that. And then mu sub d represents is the parameter in this case, whereas the previous two were statistics. Mu sub d represents the mean of all possible differences of paired data in a population. So going back to our diet example, if we were to take all possible people who went on this diet program and we subtracted their previous weight, or before weight minus the after weight, then this would be the average of all those differences. Okay, so that's the parameter. And when we're testing a claim, the claim will actually be a statement about this mu sub d, this parameter here. So how do we do this? Well, we just have to remember think about what's the probability distribution and what's our statistic. Our standardized statistic. Well, in this case, if the samples are random and dependent, and either both populations are normally distributed or the sample size is at least 30, then t is divided by we define this number t to be this quotient d bar minus mu sub d over the quotient s sub d divided by square root n. And we use that number has the t distribution with n minus 1 degrees of freedom. So because we're using the sample standard deviation, we are using the t distribution with n minus 1 degrees of freedom. And the actual process of hypothesis testing is not really that much different in all the other cases, and I didn't write them down in the notes because you can look at them in your book, but they're very similar. After you verify everything is random and in this case dependent, and the sample size is right, or the population is normally distributed, you write down your null and alternative hypothesis, identify the claim, then figure out which specify the level of significance, and then find your rejection area regions and critical values depending on what the null hypothesis is. And the null hypothesis in these problems are going to be in one of these three cases. We said mu sub d is either going to be greater than or equal to 0, or mu sub d is less than or equal to 0, or it's equal to 0. So the null hypothesis is going to be one of these. And of course these will be the alternative hypotheses, The claim that we're testing will be one of these 6 statements, okay, and we'll be using one of these. We'll be using a left-tailed test, a right-tailed test, or a two-tailed test, depending on what the alternative hypothesis is. For example, if we're assuming mu sub d is greater than or equal to 0, then we would expect the differences to be greater than or equal to 0, and the unusual differences would be less than 0, or negative, so that's why we have a left-tailed test here. All right. So that's the process. So after you find the rejection regions and the critical values, you compute this number t and see if it's in one of these shaded areas. If it is, you reject the null hypothesis. If it isn't, you don't reject it, and then you interpret the claim. So we are going to do some examples in the very next video. About 3 examples are in the notes, and stay tuned.